Hi, hello everyone. Today I'll be solving LeetCode's daily question, which is question 75, sort colors. We are given an array nums with n objects colored red, white, or blue, and we need to sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. And we'll use integers 0, 1, and 2 to represent the color red, white, and blue respectively. You must solve this problem without using the library's sort function. Okay, cool. We'll quickly bring up the whiteboard. So we basically are given three colors, red, white, and blue. Red is represented by 0, white is represented by 1, blue is represented by 2, right? For those of you who don't know, this represents the Dutch flag, and I mean, this will make more sense later. And so, yeah, so the most brute force approach that you can think of is just using inbuilt sort function, and that would be an big of n log n time complexity in most of the languages, right? But this we cannot do since it the problem says that you cannot use library sort function. And so the second approach that should come to our mind should be we'll quickly write the example. It's 20211 and then 0. And so what we can do over here is we can keep a count of how many red flags we have, how many white flags we have, how many blue flags we have, and then put it, since we want it in place, like we want it in place modification. So we'll basically put whatever number of red flags we have or zeros we have, we'll put it initially starting from 0th index to the number of red flags that we have. And so 0 till this index, frequency -1, right? And then from here we'll put this. So for this example, we have zeros frequency is 2, ones frequency is 2, two's frequency is 2, right? So from this index we'll put two indexes, we'll put 1. So let's put 0, this will be 0, 1, 1 again, and then put the remaining 2's at the very last two positions, right? So this will be an in-place modification. So since we can see over here that we will need to first make this particular map or counter, and this will take big of n approach. This will be again a single pass, so this will take O of n. And so essentially our time complexity will become big of 2n, right? Since we have to do two passes, this and then this. We can surely, should be something that should come to our mind while giving interviews. And so one of the follow-ups that is mentioned in the uh, lead code question, it says that can you come up with a one pass algorithm using only constant extra space, right? So I mean, we are using constant extra space over here, but we have a two pass algorithm, right? So we need to come up with an algorithm that basically gives you an in-place modification of nums array in just a single pass, right? So one such algorithm given, since I mentioned Dutch flag, is the Dutch flag algorithm. It's called a Dutch national flag algorithm, and I think it was made by Dijkstra. So this is the Dutch national flag problem. It was proposed by Edgar Dijkstra. And so we'll quickly just go to the pseudocode that it has. So it says that entries from 0 up till I, but not including, so 0 till I minus 1 are values that are less than mid, I to j are equal to mid, j to k are not sorted, and then k plus 1 till the end of array are greater than mid. So 0, 1, unsorted, 2, right? This is what exactly it says. So we'll quickly shift to our whiteboard. Right. So this is the Dutch national flag problem. As I mentioned, how why it has RW1B. It is represents the Dutch flag proposed by Edgar Dijkstra, and we will just quickly go towards its pseudocode. So it says that entries from 0 up to I minus 1 are values less than mid, I to uh, j minus 1 are equal to mid, and then j to k are not sorted, k plus 1 till end of array are greater than mid. So basically this says these values represent zeros, 1 not sorted, 2's, right? So let me quickly bring the whiteboard up. Okay, so the Dutch national flag algorithm states that till 0 till your low minus 1 is all zeros, right? And then from your low till your mid minus 1 are all ones, right? And then from mid till your high is unsorted. And then from high plus 1 till your end of array, so the length of array is consisting of all the twos, right? This is what we have. So the problem comes down to we need to make like sort this array based on this and this information that we have, right? So what we'll do over here is, let's suppose we can mid can have 0 1 or 2, right? So we'll have let's take the case when your array of mid is equal to 0, right? In that case, where would you want to put this particular 0? In this, somewhere over here, not over here, right? Somewhere over here. What would be the most ideal place to put 0? You can put it over somewhere over here, but the most ideal place would be to put it just after these zeros, right? And this place is nothing but your low till mid minus 1 range. So you need to put this somewhere at your low, right? So this will basically become 0 0, and so this is done. Then you once, so this is fine if you put your 0 over here. So we can say that if array of mid is equal to 0, then we'll swap uh, mid with low, right? And then since you have swapped mid with low, 1 maybe will come over here, 0 will be here, and since you have 1 over here, your sorting space will should now be reduced to this. Like you need to sort till from mid plus 1 till your high, right? So you need to increment your mid by 1, and your low should also be increased by 1, right? Since your low to mid minus 1 range consists of all the ones, so low will become equal to uh, low plus 1, right? And we'll take the second example, which is when your array of mid is equal to 1. So let's suppose if we have 1 over here, where would it make the most sense to keep this? Over here only, right? You have your L over here, your mid minus 1 over here. This is fine if we have 1 over here, right? Zeros, all ones, problem space reduced to again mid plus 1 till high. No effect on L, just no swapping, just mid is increased. So mid plus equal to 1 in this case. Then uh, sorry, array of mid, if it is equal to 2, right? Let's suppose we'll have 2 over here, right? Then we are not considering this, we are still in this range. We have 2 over here. It would make more sense to keep it somewhere in this particular range, right? If we keep it on high 2, can we not say that this part is sorted, right? And our window size is now reduced from mid till high minus 1, right? So when it was 0, our window size, when it was 1, our window size was going from mid plus 1 till your high when it was 1, and now it is going from mid till high minus 1. So what is essentially happening is you are swapping two, you are swapping your middle element with your high, and then you are also decrementing your 1 high minus 1, right? And mid will remain in its original place, that is should be fine. And we'll just quickly dry run this particular thing on one of the example test cases quickly. So our example is 202110, right? Low is over here, mid should be over here, high will be over here, right? Let's do let's start with seeing what is mid exactly. Mid is equal to 2. So when your mid is equal to 2, you need to swap mid with high. So swap both of these. This will become 0. This will become 2. High will be decremented. This will come up over here, right? Then again, mid is still over here. We'll again check your mid is equal to 0. In this case, we'll swap mid and low. Since both are pointing to the same index, no use. Mid will be incremented by 1 and low will also be incremented by 1 in this case. So low comes over here, mid comes over here. Correct. Now mid is again 0, same index, no swapping, both incremented by 1. Low comes up over here, mid comes up over here. And after this, mid is now pointing to 2. We'll swap mid with high. Our high is here. So this becomes 1, this becomes 2. High is decremented. Remove this. Mid is still now mid is pointing to 1. In this case, since mid is pointing to 1, this will execute. Mid should be incremented, so mid will come up over here. Since we have seen, it would make more sense to keep one over here only and then shift the window, since it will be in a sorted fashion in this particular window, right? And so our mid came up over here, and mid is now pointing to 1. Mid should be incremented by 1. Mid is over here, and high is over here, mid is over here, and this will be our breaking condition, right? So we'll quickly just code this up. Yep, we'll code this thing up quickly. Okay, so we have three pointers. We have our low, mid, and then high. Low is pointing to 0, mid is pointing to 0, high is pointing to length of your nums uh, -1. We have breaking condition would be when it's greater, so the while loop should continue till our mid is less than or equal to your high, right? Now we'll just quickly whatever we have written till now, we'll just quickly put these in our if else if conditions, right? Yeah. So if our nums of mid, if it is equal to 0, in this case we'll swap mid and low, uh, swap mid and low, right? And mid will be incremented by 1, low will also be incremented by 1. Elif your nums of your mid, if it is equal to 1, uh, mid should be incremented by 1, else your here will swap high and mid, right? And high should be decremented by 1. We'll just quickly write this thing down. Temp, or we can use Python build, but yeah, we'll use this. Temp will be equal to nums of mid. Your nums of mid will be equal to your nums of low. Nums of low will be equal to your temp. Let us just quickly copy this, put it over here. Uh, Instead of medium, we need to replace it with high. Put it high over here, and yeah, this should be fine. And we'll quickly run this, and it is passing test cases. We'll submit this up. It says accepted, and so this will be one pass approach as is mentioned in the follow-up, and time complexity will be big of n. The space complexity would be big of 1 since we are doing an in-place modification. And yeah, so that is pretty much it. Thank you.